In 1973, a high school girl asked one strange question, and NASA put 2 spiders on a rocket to answer it. That sounds like a joke. It is one of the most real experiments ever flown, because the place above your head is not just rockets and flags, it is the strangest laboratory humans have ever built. Up there, we have lit fires that turn into floating balls. We have watched bugs survive being thrown into raw space. We have grown twins who slowly became different people while one of them orbited the Earth. So here is the real question. What are the strangest experiments we have ever run in space, and why did we run them? Some of these answers sound made up. Every single one is verified, with dates, names, and missions. By the end, the weirdest one will turn out to be the most important. Let me give you the tour. Start with the spiders, because that is where this gets personal. In the early 70s, a 17-year-old student named Judith Miles from Massachusetts had a simple idea. A spider builds its web by feeling the pull of gravity. So what happens to a spider with no gravity at all? She entered her question in a student experiment contest. NASA picked it for the Skylab space station. 2 female garden spiders were chosen. Their names were Arabella and Anita. On July 28, 1973, they launched into orbit aboard Skylab. The first time Arabella tried to spin a web in weightlessness, it came out a disaster, a messy, lopsided tangle. Her whole instinct was wrong. There was no down to pull against. And then something quietly amazing happened. By the second day she adjusted, Arabella began spinning a proper web again. A real, organized, beautiful web in a place webs were never meant to exist. Scientists noticed the new threads were actually finer and more even than the ones she made on Earth. A spider had not just survived space, it had learned to work in it. That single fact rewired how we think about life off Earth. Remember that schoolgirl. We will come back to her, because her question turned out to be bigger than anyone guessed. But spiders were not the first living things we threw into space. Not even close. The very first animals in space were not dogs, not monkeys, not humans. They were fruit flies. February 20th, 1947. This is before NASA even existed. American scientists took a captured German V-2 rocket out to the New Mexico desert. They loaded a small capsule with fruit flies and a packet of seeds and fired it straight up. The rocket climbed past 100 kilometers, crossing the official edge of space. Why flies? Because they did not want to risk a human first. They wanted to know one thing. Would the radiation up there shred living cells? Cosmic rays were a total mystery and a real fear. The capsule parachuted back into the desert. Scientists ran to it and opened it. The flies were alive, buzzing, healthy, completely fine. That tiny result was huge. It was the first real proof that a living thing could go to space and come back okay. Now let me show you something that genuinely looks like magic. Fire. On Earth, a flame is shaped like a teardrop, pointing up. You have seen it 1,000 times, but the flame is only that shape because of gravity. Hot air rises, cool air rushes in below, and that flow stretches it into a point. In orbit, hot air does not rise. There is no up for it to rise to, so the flow stops. And the flame does the strangest thing. It pulls itself into a tiny, perfect, glowing blue sphere. It burns slow, calm, and almost silent. A little floating star you could hold in your palm. NASA studied this in an experiment called FLEX on the International Space Station. And while watching those flame balls, they stumbled onto something nobody expected. They put the flame out. The fire went dark, and the fuel droplet kept burning anyway. Invisible fire. A flame so cool you cannot see it, still quietly eating away at the fuel. They called them cool flames. A brand new kind of burning discovered by accident in orbit. Now you might be thinking, who cares about weird fire? Stay with me, because this matters more than the spiders. Understanding cool flames could lead to cleaner car engines and safer fuel here on Earth. Strange space fire. Real-world payoff. Here is the part where it stops sounding possible. Meet the toughest animal ever discovered. It is called a tardigrade. People also call it a water bear. It is smaller than a grain of salt. In 2007, the European Space Agency, not NASA this time, ran a wild test. On a mission called Photon M3, they took a batch of dried-up tardigrades and bolted them to the outside of the spacecraft. No suit, no air, no protection. Raw vacuum, deadly radiation, and freezing cold straight onto their bodies. That should kill anything. Vacuum boils your fluids. Cosmic rays tear cells apart. After 10 days exposed to open space, they brought the tardigrades back down and added water, and they woke up. They puffed back to life and walked around like nothing had happened. They became the first animal known to survive being exposed to raw outer space and live. Later, NASA flew tardigrades to the space station too to figure out the secret behind that impossible toughness. If a creature this small can take all of that, it changes what we think is possible for life out there. Some space experiments are not about sending animals up. They are about copying their tricks. Picture a gecko walking straight up a glass wall, upside down, not falling. How? It is not glue, and it is not suction. The gecko's toes are covered in millions of microscopic hairs. Those hairs get so close to the surface that an invisible atomic stickiness grabs hold. Dry, reusable, and clever. Now here is the space problem. Out in orbit, how does a robot grab a floating object? Suction cups need air, and there is no air. Magnets only grab metal. Most space junk is neither. So engineers at NASA's JPL built a gripper using the exact same gecko trick. A dry adhesive pad that sticks when you want it to, lets go when you want it to, and works in the vacuum of space. They tested it in weightlessness, and the gripper calmly caught objects floating in mid-air. It can grab smooth objects up to 1 meter wide. Someday, robots like this may clean dangerous junk out of orbit. Quick question for you before we go on. Have you ever seen a flash of light with your eyes completely closed? Now imagine that happening over and over in the dark and nobody can explain why. That is real, and it happens in space. It started back on Apollo 11. Neil Armstrong and Buzz Aldrin reported it on the way to the moon. With their eyes shut, in total darkness, they kept seeing flashes, little spots, streaks, and clouds of light. At first it sounded like exhaustion or imagination. But every crew kept reporting the same thing. So on Apollo 16 and 17, astronauts wore a special detector strapped to their heads to catch it. The answer is genuinely unsettling. They were seeing cosmic rays. High-energy particles from deep space were passing straight through their eyeballs and zapping the retina from the inside. The flash is your own eye reacting to radiation. You are literally seeing the radiation that is hitting you. On Earth, our atmosphere blocks almost all of it. Up there, you are wide open to the universe, even when your eyes are not. Now here is the turn I promised you. You might think all of this is just fun trivia. It is the opposite. These strange little experiments are not the silly side of space. They are the most important science we do up there. The spider taught us that life can learn and adapt without gravity. That is the foundation for keeping humans healthy on long missions. The flame ball is teaching us how fire and fuel really work, which means cleaner engines and safer spacecraft. The water bear is teaching us how life survives radiation, which could one day protect human cells on the way to Mars. The Gecko gripper is building the robots that will repair stations and clean up orbit so it stays usable. And the light flashes are warning us in advance about the radiation that could hurt astronauts on deep space trips. Here is the big idea worth keeping. We did not learn the most about space by being serious. We learned it by being curious about the weird stuff. Asking a strange question is not a waste of time. In space, it is often the entire point. Which brings us to the strangest experiment of all, and the most human one. To study what space does to the human body, NASA needed a perfect comparison. They found one in a single family. Scott and Mark Kelly were identical twin astronauts. Same DNA, same age, same life. So NASA made a plan. Send one twin to space for nearly a year. Keep the other one home as the control. In 2015, Scott launched to the International Space Station and stayed for 340 days, almost a full year, while his brother Mark lived a normal life on the ground. Doctors tracked everything, their blood, their genes, their gut bacteria, their minds, side by side, and slowly the twin in space started to change in ways the twin on Earth did not. The little caps on the ends of his chromosomes, called telomeres, actually grew longer in orbit. Thousands of his genes switched their activity up or down, his gut bacteria shifted. Even some thinking tests changed. This sounds like science fiction, but it is fully documented in a major published study. Now here is the gentle relief. When Scott came home, most of those changes slowly returned to normal. His telomeres shrank back down, most of his genes settled. But a small piece of him never quite went back. About 7% of his gene activity stayed changed months after landing. A quiet, permanent souvenir from space. His twin brother is now the closest thing we have to a before and after photo of what space does to a person. So, what are the strangest experiments we have ever run in space? Spiders that learned to weave in the dark. A flame folded into a silent blue ball. A creature smaller than salt that shrugged off raw space. A gecko's foot reborn as a robot's hand. Astronauts watching radiation flash inside their own eyes. and twin brothers who slowly became different people. Every one of them sounded like a joke at first. Every one of them taught us something we could not have learned any other way. And now, the way I promised, let's go all the way back to the very beginning. Back to 1973, back to a 17-year-old girl named Judith Miles sitting in a classroom. She did not build a rocket, she did not have a lab, she just asked one strange, simple question about a spider. And that question flew to space, taught us that life can adapt beyond Earth, and is still in the textbooks today. You do not need a spacesuit to do science, you just need to notice something weird and refuse to ignore it. So here is my honest question for you. What is the strangest thing you have ever wondered about? Drop it in the comments. I read them. And if you want more space stories that sound impossible but are completely real, subscribe. The next one is even stranger, because somewhere up there, right now, another strange little experiment is quietly rewriting what we know. Good night, explorers.